Hello, everyone. My name is Steve Adolf, and welcome to another installment of Practical Safe from the Dining Room Table. This installment is part 2 of our lessons on wsjf, weighted shortest job first. And in part 2, we're going to be looking at an example of a team calculating weighted shortest job first. So as you remember, weighted shortest job first is the prioritization model that's used in SAFE to sequence jobs, features, capabilities, and epics to get the best economic benefit. So what we want to do, understand why is it useful, how is it calculated, and how is wsjf used to facilitate the prioritization discussion of backlog items. This second part here is really mostly about how do we use it to facilitate the conversations. So the disclaimer, my usual disclaimers, these are my personal opinions and perspectives based on my experience with clients. They absolutely do not represent the views of Scaled Agile Incorporated nor of my employer. And while you may gain some insight into SAFE, this really is not intended to serve as exam preparation material. So here's the thing about cost of delay and weighted shortest job first. Everybody overthinks it. So here people are thinking they have to somehow reduce cost of delay down into future cash flows and comparisons. That's not what you have to do. Think about what we're using it for. We just want to answer this question. Should we do A before B or B before A? That is all we need to use it for. So that means we don't have to have a precise calculation, a precise number. We just have to be able to have a defensible argument a defensible economic argument as to why we did either A before B or B before A. So then, that means we could use a technique that's simple and reasonably accurate, borrow the relative comparison techniques that you often use in agile sizing, right? Where we take a piece of work and we compare it to other pieces of work that we have done in past. And then that tells us how big that piece of work is. So here you see a classic sizing chart and the team collaboratively trying to size a piece of work. We can do the exact same thing with value. If we can compare size relatively, why can't we compare value relatively? So we can do exactly the same thing, and we can use also the Fibonacci sequence. Again, because the Fibonacci sequence gives us a very nice progression. So, and we can even use planning poker. Now, some of you may go, look, I can't give my CEO, my CIO, a deck of planning poker cards. They're just not going to take it seriously. Fine. Call it wide band Delphi then. That is basically what planning poker is. So then it sounds much more something that would come out of an MBA program, and you'll get over that issue. Point is, there are lots of collaborative ways to get people to open up and discuss how big a feature is and also how valuable a feature and what makes a feature valuable to them. So let's say we have 5 features and we got to ask, which one should we do first? And so we start by calculating the value of that feature, right? We calculate it as cost of delay. And you remember from our previous video, we said cost of delay has 3 components: business value, time criticality, opportunity enabler, or risk reduction. So here now is our 5 features listed out in this table. So what we do is we start calculating cost of delay by calculating one column in this table, in this case, business value. We start with business value. We just focus on that for the moment. And what we do is just like we would do for classic sizing, we would ask which of the items that we have has the least business value when compared to the others. So just like you would do in sizing and saying, to find our one, which is the smallest story we have, you say, which of these features, which of these capabilities, which of these epics has the least business value compared to the others? And you declare that one your one. So let's say book detail is 1. Moving on. Now we estimate the business value of the other items, the other features, the other capabilities, the other epics relative to that one. And so now we said, hey, shipping method is a 5. That means it has 5 times more business value than book detail. Okay, so we want to maintain consistency. If we say something's a 5, it means it has 5 times more value than a 1. And we do the same for all the other items. So flexible search has 20 times more business value than book detail. It has 4 times more business value than shipping method or profile management. Then we move on to time criticality. And we just work on time criticality as itself. So in this case, it happens to be that book detail has the least business or at least time criticality. That might not have been the case. It could have been one of the others. But in this situation here, book detail has the least time criticality. And therefore, we can now go through the other items and say relative to book detail, what is their time criticality? Okay, we can see that profile management has 3 times more time criticality than book detail. Flexible search and shopping cart and shipping method 8 times. Do the same thing for opportunity enablement and risk reduction. Now, what you do is to get the cost of delay, you sum up the business value, time criticality, opportunity enablement, and risk reduction for each feature. And that gives you these numbers. Okay, so that is our cost of delay. That is the value of that feature. So strictly based on value, we would be doing flexible search first, followed by shopping cart, followed by profile management, shipping method, and then book detail. Now we bring in the size. And the size, in this case, you can see we have flexible search is fairly large, so shopping cart and the others are small to moderate. I'm going to make this one point about size again, my favorite mantra. Remember, those who do the work, size the work. When you are doing this exercise, you need to have someone who's a representative of the team or the development organization to be there and to actually put the legitimate size on this work. Right? You need the input of those who will actually do the work to tell you how big that unit of work is, if this is going to be reasonable and valid. All right, so now we go through the calculation. We calculate wsjf, weighted shortest job first, by dividing value by size, and we get our numbers. And guess which feature gets done first according to this? That, of course, is going to be shipping method. And look, our most valuable feature actually falls out last. So here is our priority order. Here is the order that we should be doing these features in. What do you think, of course, the reaction is? Likely. And believe it or not, when I've done this exercise, this is almost usually the reaction. What the bleep? No way. This is garbage, bogus, totally wrong. So what do? Okay. This is the first temptation. Everybody's going to say, well, what do I got to do to boost the value of my valuable feature to make it first? Okay, let's get something. If we went correctly and in a disciplined manner, i.e., for example, using planning poker, having our conversations, then the values, the relative values that we established for each of these features should be reasonable. So goosing the value just so that you can make it first is really saying, I'm going to ignore what this is telling me about the economic outcomes and just make a fiat choice here. So resist this. But look at why this is really happening, okay? Our 2 most valuable features are near the bottom of the priority list because they're big. They're huge. And that is what is causing our problem for us. So yes, flexible search does give us 36 units of value, cost of delay, But because it's so big, it goes right down to the bottom. And you saw in the previous part 1 of this video series the disadvantage of going ahead anyways, and the economic outcome, the disadvantaged economic outcome you're going to get if you decide to do this regardless. So shipping method becomes our best choice because it's a fairly small item here. So what do? Well, still everyone's going, I need that. Well, this is where you start taking advantage of the Pareto principle and looking at often 80% of a feature's value comes from 20% of its size. So really what I call this is look for the pearl in the oyster. What's the real pearl out there? And so ask the question, where's the pearl? And you often get the responses, well, what I really need now, right? And all of a sudden what that can do is make the size of the feature, because here's the problem with really large features. They plug up the flow, right? Everything you've learned about SAFe is that smaller pieces of work go through the system faster. When we try to force these large pieces of work, what we're going to start seeing growing queue lengths. We're going to see expanded work in progress limits. So this is violating a lot of the principles that we have in SAFe. So bottom line is we want smaller work items because they go through the system faster with more predictability. So what the real utility of weighted shortest job first for us, it says, okay, these are valuable, but the reason we're not doing them is because they're big. Can we make them smaller so that they can move through the system faster with greater predictability? And though here you see, our product manager comes by and says, well, if we break out this fuzzy search portion of the flexible search, it reduces the value a bit, but it's not critical to our first release, and it's a lot of work. So the result of that is, okay, it reduces a lot of our opportunity enablement risk reduction. So it reduces our overall cost of delay, but it dramatically reduces the size. And now we notice its wsjf goes up. So this changes now our priority order to shipping method is still first, but flexible search is right after that. And so the team is really going, okay, maybe I can live with it. Maybe you still can't. Maybe by fiat somebody says, no, we're still doing flexible search first, but we'll do the smaller version, right? WSJF is not meant to be a straitjacket, right? It is meant to be a facilitation technique that helps inform the team to come to an informed consensus about sequencing the work. If you truly decide to move that flexible search to the top, at least you know the economic benefit that you're giving up. But the important thing you saw in this exercise, people are collaborating, trying to understand the feature, going through the planning poker, or different methods for determining the value. It's really about collaboratively coming to that economically sound and informed consensus for sequencing the work. So in a lot of ways, this is really a facilitation technique. So, summarize. WSJF is a facilitation technique for creating an informed and economically sound consensus for sequencing work. So don't overthink WSJF, right? It's just a mechanism for us to be able to defensively say why we're doing one feature before another. You can use classical relative comparison techniques for estimating value, the same ones that you would use for size. You can use like planning poker, white elephant, all those lovely techniques. If you have an executive that is not keen on calling it planning poker, or then call it wideband Delphi. Okay. Resist the temptation to doctor the values if you don't get the expected results. Really look at why did you get the unexpected results and apply the Pareto principle, because 9 times out of 10, it's because the feature is excessively large. So can you use it to find the pearl in the feature? And therefore get smaller items, which do flow through the system with faster and with more predictability. So I hope that gives you sort of a practical explanation of wsjf. I hope you enjoyed this video. My name is Steve Adel, and as the Safe Agilists like to say, be safe.